Hi again. So we have reached one of the last exercises for this chapter and this year. We will be dealing with quadratic probing. So we'll be solving two exercises here, exercise 16 and exercise 2. So in exercise 16, they are telling us to search for an element in the hash table, and in exercise 2, they are asking us to delete an element, and I will solve also the insertion of an element into such hash table using the quadratic probing. So in quadratic probing, first we try to insert the element in its index, and if it's filled with some other element, so I'll check with +1, so the index, so the hashing value, original hashing value of the element +1, and then plus 2 power 2, and then so on until we reach I square, and we do that m over 2 time, where m is the number of elements in a circular way. So we do at most m over 2 iteration, where m is the size of the hashing table. So they are telling us that we need to do a trace here. So we have m equal to 12, and we need to insert the elements e, I, q, m, b, y, n, and j, and they are telling us that the hashing values of each of these functions are as the following, and we need to insert the element. So I have already done this, and let's see why we have this output. So let's check it together. So we have he, so the element e, its hashing value is equal to 5. So at first 5 is empty, so I can add the element e at index 5. Then we have to insert I, which is at index 9. So index 9 is empty till now, so I can add the element I. Then we have q. Q is its hashing value is equal to 5. However, 5 already contains the element e, so by quadratic probing I need to check. So the hashing of q is equal to 5. So 5 is occupied. So I try 5 plus 1 square, which is equal to 6. So 6 is empty, so I can place ku. Then I have m. So m again, its hashing value is equal to 5. So I need to check 5 plus 1, 5, and then 5 plus 1 square, so equals to 6. 6 is already filled. Then I need to check 5 plus 2 power 2. 5 plus 4, which is equal to 9. So 9 already is occupied by I, so I need to check 5 plus 3 power 2, which is 5 plus 9, which is equal to 14. So so we will do that. So from 5 I will count 9 steps: 1, 2, 3, 4, 5, 6, 7, 8, 9. So at index 2 it's empty, so I can add m. Then we have b. So h of b is equal to 2. So 2 is already filled by m, so I need to check 2 plus 1. 2 plus 1 power 2, so it's equal to 3. So 3 is empty. Now I can add b. Then we have y. The hashing of y is equal to 5. So we know that 5 is filled. 5 plus 1 is filled. 5 plus 4 is already filled. 5 plus 9 is already filled. So after 5 plus 9 is 5 plus 4 power 2, it's equal 5 plus 16. So we have reached here 5 plus 9. So 9, 10, 11, 12, 13, 14, 15, and let's count again. So 9, 10, 11, 12, 13, 14, 15, 16. So it's already filled. After 16 we have 5 plus 25. So 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we already done approximately 5 iterations, so we can still make one. So 5 plus 6 power 2, it's equal to 36. So if we do that again, we will reach a cell which is not empty. So we will conclude that we cannot add the element y. Then we have the element n. We need to add n, which its hashing value is equal to 2. So 2 is already occupied. 2 plus 1 is already occupied. And then we do 2 plus 2 power 2, which is equal to 2 plus 4. So I am here. I count 1, 2, 3, 4. So it's already occupied. And then I do 2 plus 3 power 2. It's 2 plus 9. So I'm here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So index 11 is empty, and I can add n at index 11. Then I have the index, the element j, which has to 2. So if you will do it by your own, you will notice that we cannot add the element 2 into such hash table. So the insertion will fail because we will do approximately 7 iterations, and at each time we will load on a filled cell. So let's move. So this is the exercise 16. If you go up to exercise 2, so it's the same question. However, we need to delete an element. So let's see it quickly here. So we have this table after inserting the elements AA, BB, CC, DD, and then as you can see, all these element hashes to the same hashing value, which is equal to 2, and we are using the quadratic probing. So whenever I need to delete the element E, so E here is BB, so we know that the hashing of A is equal to, so first we have added AA, then we have added BB, then CC, then DD, because we see the jumps, the hop that we are seeing here. So whenever I'm deleting BB, I need to reallocate CC into BB and DD into CC. So I need to do some shifting. So the deleting part is not that easy. So let's move to the implementation. So we have a hashing table. So the hashing table contains an element, and these elements are of type char. We have the hashing value, and we need to adjust. I have already wrote the creation of a hashing table, which I just place the character 0 to say that all the cells are empty. I have a small function print in order to print the hashing table, and we will write the insertion, and deletion of an element. As for the test case, is the one that we have already seen. So I'm adding here the elements. So this is the table that we have seen after inserting all these elements, and we can check that I cannot add Y, and I cannot add J, and I can search for some elements of the same elements that I've tried to add it. So I can find all these except Y and J because they are not in the table, and then I try to delete B from the hash table. So let's move to the insertion. So for the function, it takes the hashing table, the size of the hashing table, and the element to be inserted. So obviously, if I hash the element and its cell is empty, I can directly place it in there. So I will declare some variables I and B and step, because if the cell is filled by some other element, I need to do some iteration. So the steps will help me count the number of steps in order to say that I can insert the element or I cannot insert the element. So for the hashing value, so I will call the hashing function on the element. So the hashing function takes an element and a size. So the element here is E, and its the size is size. So I have found the hashing value. So I need to check the array. So if it's equal to it's an empty, so it's equal to the character 0, it means that the cell is empty. So I just need to place the element there, so the element E, and I will return 1 because I have successfully added this element. Otherwise, I need to try to do the quadratic probing, and I need to count the number of steps. So for that, I need a number, so this is the number, and I need the step. So there's a difference here because in step, so I can use just 1. So let's keep step. So step will start from 1. And then, so as long as the step is less than size over 2, so this is the number of iteration. Of course, at the end, I need to do step plus plus. So I need to check. So if the hashing of the next element, so it's equal to v hash plus step multiple steps. So the first time so we already know that v hash is not equal to 0 because I have reached this part. So first I'll do v hash plus 1 power 2, and of course all these is modulo size because I can do circular rotation of the array. So if it's equal to 0, it means if it's empty, I just need to add the element there. So in this, I will add the element E, and of course, I will return 1. Otherwise, in both cases, I will increment the number of steps. So whenever I reach here, it means that I couldn't add the element, and I will return a lovely 0. So let me go down here and just comment this part in order to check if the insertion succeeds or not. So let's execute. So we had here just I have wrote less than, it's over. So after executing we will have the output, and yes, I cannot add y and I cannot add j. So this is for the inserting of an element, so it's not a difficult exercise. So the same applies for searching an element, so it's the same as inserting. So let me copy paste and just do some modification. So here we don't need the number, so we need the iteration and stuff. So maybe in searching we need it. So let me check. So and again I need to check the hashing value of the element that I need to search for it, and I will combine both these into the while loop. So I will start from nv equal to 1. So here I will use nb for the number of iteration. However, steps, it will be equal to 0, start from 0, because I will be starting from v hash. So as long as the number of iteration is less than size over 2, and if the hashing value is equal to the element e, I will return 1. So, and in both cases I will add the steps and I will add the counter. So the step is it will be used for the incrementation, and the number for number of iterations. So we can remove the number here, so we can just use step -1 or nb -1 if you want to do that. So so we can do that here. So let me remove step, so we don't need the variable step. And here, instead of step, we will use number -1. So, and of course, all is modulo size. So let me do the searching part and check if it works. So let me run. So yes, y and j cannot be found. However, all of these can be found. So the last part is the deletion. So the deletion of an element from the hash table. So again, we have these number of steps that we need to take count of, and whenever I found the element e, I need to shift all its remaining elements. So I need to loop again. So I need to continue the number of iteration, the m over 2, the size over 2 times, and check if there's some elements that hash the same hashing elements, and I need to reallocate them into the original place. So for that, I'll be using int I. So I for the so there's no I here. So I'll be using number, and b, the number of steps. So here I'll be using number and steps, so that in order, because we have some complicated expressions here, so I don't want to have complicated expressions. So I need the position and all, because I need to copy one element into its oldest position. So for that, I'll be saving some positions. So again, I will be calculating the hashing value of the element e. And again, I will start from 1, and step I will start from 0. You can get rid of one of these. However, whenever we are writing later here some expression, it will be very unreadable. So we will be looping again and size over 2 times. So as long as the number is less than number 2 times, so I will try to check the element. So if I can find the element here, it means that it's in the table and I need to delete. So to delete and shift, potential shifting. So this is here what I will do. Otherwise, if I couldn't find the element, I just need to increment the number of iterations. And in the case where so it's a bit far here, so I need to increment number of iteration, and of course I need to increment the number of steps. And in case I finished and I couldn't find or delete an element, I will return 0. So this is the biggest loop. So if I found the element, I need to do some deletion. So again, I need to continue the number of iterations. So for that, I will save the position here. So the position is equal to this v hash, just to say that later on, whenever I will be looping, if I need to reallocate an element, I will place it in index position. So I will continue the loop. So again, I will have while and b size less than 2, because I need to continue the number of iterations. So here I'll just do the reallocation. So again, in this while loop, as we have done here at the end of this while loop, and if I found the element, of course, I will return 1, because obviously I will delete the element. And at the end of the while loop, I will increment the number plus plus, because I need to end this loop. I need to stop the condition. So at each iteration, I will increment the number of steps, because I will be calculating the v hashing, the hashing of the next element. So what I will do that, again, I will check if the next element using the quadratic probing is one of it hashes the same element of me. So it means that if the next element in the hashing in the table, it hashes to the same hashing value, and we have the same hashing value. So if the next cell in the hashing probing is different than 0, it means if it's not empty, and if the hashing value is equal to the same hashing value of me, and if all of these it's hashing, so I need to call the function hash function. So the element there, if it hashes, so the hashing function takes size. If it hashes to the same original hashing value here, so I need to shift. So the element which is, I will not use nb minus 1, right? I will use a step, because we have seen that it's better to use a step, because it will be very cumbersome. So let me rewrite it step, multiple step, a modulo size. So right, so here it means that the element which is here in hash v hash step multiple step, it means it should go into the position, because now position is empty, because this is the position that it needs to be deleted. So we will do some stuff here. So we will check later that if we do that, in some cases we will be looping indefinitely, because we will be, for example, in case we have the elements that hashes to the same hashing value, and the probing will get the same steps. So we need to just take into account the fact that we don't loop. So if we need to save the value all. So if we reach the same hashing hashing value, I need to stop, because it means that we have ended. So if old, so now I will talk about old. I will save the old, it's the oldest value. So after that, in the position, so in the original position, I would place this element, the new element, and of course I need to place 0 in this one, because now this one is empty. And of course I need to save the old, which is equal to pause, and the newest empty position is equal to this. So let me repeat quickly. So this is it for the function delete. So in delete, we start by doing the iterations, and if I don't find the element, I just need to return 0 after size over 2 iterations. So if I found the element E, I need to try to shift all the remaining elements. So in order to shift, so I need to continue the number of iterations. So we have the same while loop here. So I need to increment the number, and after doing the while loop, because I've already found the element, I need to return 1. And while doing that, I know that this element it's found, so I need to place 0. So what I will do that is I will place in v hash plus step multiple step. So I've incremented the step, so I've now into the next element in the table, and I have placed it into the empty cell, and I have emptied the original one. So let us take an example. I need here to delete the element B. So if we go back, B, so where's the question? So let's go down. So B, it hashes to it's 16. it has just two element 2, and however it has j n and j as a successor, so there's no j because we couldn't add j, so we have n. So again, let's go back and we have b and n. So b is here and n is here. So obviously if I delete b, n should jump and get into b. So let's rerun and execute. So yes, after deleting b, n jumped in place of b. So let's delete the first element here, which is e, and see what happens. So we know that in order to execute, we know that we have a q m, which has to the same values. Why we couldn't add it? So we need to check q and m, what happens with q and m. So q is here and m is here. So obviously q should come in place of e and m should come in place of q. So yes, we have q in place of e, so it's index 5 now, and m, which was at index 2, now is at index 6. And this is it. So this is the solution. It's not that easy, especially in the deletion and this condition, because forcibly in this example, so if I omit this part and I re-execute the element, you will see that, and if you do some calculations here, you will see that in 2 and 6, so at the same time we'll switching 2 and 6 and 6 and 2, so it will still like this into number of iterations equal to size over 2. So at the end we'll keep m in 2, and however in 6 will be equal to empty cell. So as you can see, so because why? Because at each iteration I'm copying m into the empty cell and the empty cell into m. So it's like this, and at the end, since the number of iterations is equal to that, I will end to m. So whenever I'm doing that, I will not copy an old element to its oldest element. So I'm keeping the oldest position for that to not to have this problem. And this is it for this exercise. If you have any questions, do not hesitate to write to me and I will answer you back. And again, thanks for watching.